we like tape this in?
Yep, you're gonna tape. So you guys are gonna tape this in your notes after we're done with it. All right. Today's notes are. Hang on 1 second. Let's get my pens out. So today's notes are going to be titled 2.2 Parallel Lines and Transversals.
Are we writing on this one?
Yes.
All right.
You're writing on both. All right. So today is 2.2 Parallel Lines and Transversals. Okay. Now, once you have that title down, we're going to take this page right here and turn them sideways. Okay? What we're going to be talking about today is essentially the basic vocabulary of that, which is location description, alternate, same side, interior, and exterior. Okay? You guys should have seen these before. So the first one we're going to talk about are corresponding. All right. My bad. Alternate, however, let me phrase that. Let me put this in here, though. Angles that are alternating sides of a transversal. Interiors between the lines. Same side as the angles that are on the same side of the transversal. And exterior are outside the lines. A transversal, okay, is this right here. Cuts between two lines. That's what a transversal is. Now, let's talk about the corresponding angle postulate. As you remember, when we talked about postulates are known defined laws in mathematics, right? Notice that the rest of these are all theorems. That means they're technically not proven. We just assume that they are in the situation because we've used it so much that it's pretty much can be treated as a law. Just like in science where you have a law of gravity and then you have a theory of, or I'll use an example in bio for that one, and then you have the theory of how muscles work. We actually have never proven that muscles actually work using electricity and stringing across essentially a bunch of fibers. Okay, when it wants to contract or expand. That's a theory. So, yes, corresponding angles.
Is there no way to prove said theory? Or?
Eventually they will, but it takes time. Like I said, this kind of goes back to the thing I mentioned about parallel lines with NASA. They just proved that like in the last decade.
That parallel lines are actually...
Parallel lines, yes. Yep, the parallel lines are actually parallel lines. Before then it was a theorem, not a postulate. It's now been upgraded to postulate. Okay, it's a big deal when something like that happens because it changes a lot of mathematical proofs in terms of the terminology and wording so that we don't have to show extra steps to prove it. Okay, which makes things faster in computers and calculations. Okay, now let's talk about A and E in these transversals down in these parallel lines and transversals. So M is parallel to N, and we have the transversal going through it. Corresponding angles, okay, are angles that and corresponding angles are congruent. They're angles that are on the transversal and on the parallel line. Okay, so they are A and E. Okay. Two other options would be, for example, B and F or D and H. They're angles that are basically, if you were to push these lines back together and make a single line and they overlap, they would be the same dimension and the same size. Right?
Yeah.
Okay. And again, corresponding angles are congruent. Now, to note on that, a good way to make sure that you understand that, though, in terms of wording, is there will be one interior and one exterior. Okay? In the same location. Okay. Now, the next one we'll talk about is alternate interior. We're going alternate exterior. We'll go around like this. Alternate exterior angles, on the other hand, are also congruent, like angle B and H. Okay, so this guy here and this guy here. Okay. Notice I'm using 3 lines to describe the angle, 3 lines to describe the angle. That's how we show congruency. Okay, there's sometimes you'll end up using 4 arcs, sometimes 5 arcs to make sure the angle's congruent because you have 4 other angles that are congruent. Can't use the same dimension of lines twice. If you want to use different colors, that's fine. I just caution you because you need to make sure you don't accidentally say, oh, these two are congruent because they have the same number of arcs on them. No, careful. Okay. Now, same side interior angles are supplementary. Okay. Which means they are 2 angles that add together to give me 180. We talked about that yesterday. Right? So,
why do you have 2 angles plus 180?
I'm just saying, I'm putting that into words. 2 angles plus 180. There are 2 angles that add to 180. I wrote it out in terms of literal math language.
Okay.
So I'm saying that they are 2 angles that add to 180. So put a that in there. And put a 2 there. Okay? I'm shorthanding it. And for those of you who are still confused, what I mean by that is this. 2 angles that add to 180. Okay? Which is why I said 2 angles add to 180. Okay? Just a language thing. I'm just shorthanding it. Okay? If that confuses you, write it out in words. All right? Now, that means that we have a possibility for CF or DE. Let's do CF. So him and him. And that makes sense, and here's why. If I were to create a second transversal that goes through, I don't really care about the angles, but I care about the fact that it's another transversal. Okay, go through right there. All right. What do all the angles add together to in a 4-sided polygon? Doesn't matter if it's quadrilateral, trapezoid, rectangle, square. Doesn't matter. What do the angles add up to every single time? No. 360. It's okay. But yes, 360. Okay. They add to 360, which is why 2 interior angles like that have to equal 180. Right? Make sense? Yeah. Okay. Now, that being said, it also stands true for exterior as well. So same side, exterior angles, or exteriors. Yeah, I'll put angle in the end. That's fine. Hold on. All right. So same side exteriors are supplementary as well. It says supplementary. Sorry. So angles B and angle G, or angle A and angle H. B and G are right here. A and H are right here. They also can be supplementary. Okay? Again, if you were to squish that transversal together, add the 2 lines together, well, you get a straight line right here, right? If I squish the transversal up, so again, let's just pretend we're looking at G here, and we move him up to here. We have B and G. That forms a straight line. They have to equal 180 degrees, right? All right. Now, the last one we're going to talk about over here is alternate interior angles. This is the one that you should remember the most from like lower school, okay?
Yeah.
Which is this guy, okay? Let's talk about angles D and F. Alternate interior angles are congruent. D is here, and F is here. They're alternate interior because if you were to draw a line, kind of get a derpy looking Z here, but a Z nonetheless. And the insides of that Z are congruent. All right? And that is literally it for the first page. Okay? Now we're going to go on and move on to the examples in the next recording.